Now we'll see the bottom up approach for this. So if you've seen this top-down approach, we were actually going from top to bottom. Like from top we started and we went till leaf node. From the leaf node we again get back and then we calculated the top one. In the bottom up approach, that is also called the tabulation. So you have a table here, if it is 1D or if it is 2D, doesn't matter. Your table here, you initialize this, and by the first elements you fill the next, by these elements you fill the next, and then how you will get the till the last. That's how happen here. So how to solve this? Again, by the top down approach, again I will take an example. So example could be the easy one, that is 1 2 3 1, right? This is the example given. How to apply the bottom up approach? So what we'll do, like first there will be a basic check. If the length is 0, then we'll return 0. If length is 0, return 0. This is the base case. Now we will create a memory, right? A memory array, just like you created another, that is length plus 1. So here you have 4 elements, 0 1 2 3 4 5. Now basic initialization. So in the tabulation method, we first step is do the initialization. So we'll initialize like whatever the value of f of 0. If someone asks you f of 0, right? So that is 0. If length is 0, then you need to return 0. That we initialize. And the first element will be actually the base element. So we'll initialize with the base element. I mean the memo of 1 would be nums of 0. Because here we have the maximum here, right? So for this the maximum is 1. So we have 1 here. Now we'll again run a loop, right? We'll loop this from here, from I equals to 1, like from I equals to 1 till the last. We'll loop it here. So what you can have, we can have a temporary variable called value, current value, that is the nums of I. So I is 1 here, right? We started the loop with 1. So now your value is 1. Now you'll have two choices, like memo of I plus 1. You need to calculate the I plus 1, right? So memo of I plus 1, the normal. Max of your memo of I, right? Means you have not included this. Same thing, you are not included this. And if you included this, then memo of I minus 1 plus value. What is the value? These are the basic condition. So if you have included the current value, then you can't go to the I1, right? Because that is the adjacent. And if you have not included the current, then you can consider the adjacent one, the basics, right? So we are sending here, right? If I equals to 1. So now I equals to 1, so you need to calculate the I plus 1, that is 2. So to calculate 2, you have two choices, right? Value is 1. So what are the two choices? Either you can include the I minus 1, right? Either we'll go with this. Either I memo of I, you can consider memo of I. Memo of I is 1, right? Or you can consider the value, that is 1. That is 1. Memo of I, the value we have, that is value of I. I is your 1 here. So you can have 1 or you can have mem of I minus 1. Mem of I minus 1 is 0, 0. So whatever is the max is 1 actually. So here you will have 1. Now I'll go here 3. You will calculate mem of 3. So now the I is 2, right? So you have two choices. Max of mem of 2, that is 1, or mem of 2 minus 1, that is 1. So you can have 1 plus the current value. Current value is value that is the 2, because I value is 2, right? So you have 2. So you can have either 1 or you can have 1 plus 2, that is 3. So here you will have 3, right? To calculate 4, now again, like to calculate 4, you will have I value, that is value of I, that is 3. So now you have two choices. Either you can get 3 or you can get the current value, that is 3 plus I minus 1, that is 1, 2. So you can have either 3 or you can have 3 plus 1, that is 4. So max of this is 4. So here you will have 4. So this is actually your bottom-up approach to filling array. That's how you can fill it, like at the end. So that's how we fill it, and we actually ask f of 4. So we'll directly return this 4 here. So the code is simple. Like in the next lecture, we'll code this. I will create a code for you if you want here. That is actually, the code is very simple for this. First condition will be if this is the pseudocode I will write, like the main code I will write there. If length equals to 0, then you need to return 0. This is the base condition, right? Then the memory array, you will initialize it. Memory of 0 equals to 0, right? And memory of 1 equals to num of 0, right? This we have discussed. Now we'll run a loop, iterative loop, that is I equals to 1, right? From 1 to I is less than nums dot length minus 1, nums dot length, thus still the length will run, right? Minus 1 we won't run. And I plus plus. What we'll do, we will take the value here, right? A temporary variable that will have the value of the current element, right? And here we'll have the initialization, mem of I plus 1, the next element we are initializing, that is max of either memo of I if you're not included, or if you're included, then memo of I minus 1 plus the current element. Current element is value. So whatever is the greater than this, it will return. Whatever the max of this too, it will return. And at the last, before this, you need to return just the num of whatever the length they are asked. Num of length. So this is a code. In the next video, I will code this.